Okay, so next section here, finding the equation of a line. We've done lots of stuff with this before. Anytime you're trying to find an equation of a line, you need at least 2 points, okay? If you have 2 points, you can use either of these different methods to find an equation for a line. Slope-intercept form is probably that one that you're most familiar with, right? Where that M stands for the slope, which is like a rise and a run. And then the B is that y-intercept. So what you're going to do is you're going to plug in whatever your M value is and a point. So if you can find your slope and a point, then you can kick out a B. And then when you rewrite your final equation, make sure that you have your slope in there and you have your y-intercept in there. Okay, again, that should be review stuff. Now this one here, point slope form, we talked briefly about this the other day. This was the one that you didn't remember as well. So how this one works, so you've got a y minus, and then this y1 is our y coordinate from like our ordered pair, equals, you've got your slope again, and then parentheses x minus, and then that's your x coordinate there. So you would plug in for the y1, the m, and the y2. Okay, and then plug in either of the points that they give you, and then whatever your slope is, and then that is another way of writing a line. Okay, so first example here, this should be in your packets. Spring is 23 inches long and has a 3-pound weight attached. Its length increases 3 inches with each additional pound of weight added. This is a constant increase situation. Write a formula relating the length, spring length, and weight W, and then graph the equation. Okay, so let's start off here with information we know. So we know that the spring is 23 inches long when it's 3 pounds, okay? Our two pieces of information here are the length and the weight. Which of those do you think is the x value, or like the independent value? Do you think it's the weight, or do you think it's the length? Which one determines the other one? The weight would determine the length of the spring, right? Because if it's a heavier weight on the spring, it's probably going to make the spring longer, right? So if we know the weight, that's going to determine the length. So in this case, our W is going to be like our x value, or our independent, and then our length is going to be our y value. So currently what we have is if it's 23 inches long for the length, or like the y, then our weight is at 3 pounds. So what that would act as, that would be like an ordered pair that's going to be in this equation, okay? So because we know that at 3 pounds, it's going to be 23 inches long. We also know it's going to be a constant increase in this situation. And then each time, it's going to increase 3 inches per pound. Okay, what do you think that 3 inches per pound stands for in our problem? Do you think that'd be another ordered pair? Do you think that would be the slope? Do you think that would be the y-intercept? That would be the slope, because that's the amount we're changing each time. So here, this increase of 3 inches, that's going to be like our slope value. Okay, so, and we could write that as like our m is equal to 3. It's 3 over 1 if you want to do it like that, where it's 3 inches for every pound. So the top number's inches, bottom number's pounds. Okay, so then using that, we want to come up with an equation. We can either do the point slope one, or we can do the slope intercept one. Since we're graphing here, slope intercept might be a little bit easier, because then we can have like our y-intercept value and then, you know, go up by whatever. So maybe we'll try that one. So we'll go y equals mx plus b. And what's going to go where in that equation? Yep. Put that 3 in there, or 3 over 1, however you want to write it for the m. Okay, what else? The 3 and the 23, right? So isn't that an x and a y we could plug in? Yeah, absolutely. So the x would be a 3. Don't know our b value, but the y is a 23. So then isn't that something we could solve and get that b value? Yeah, because 3 times 3 is 9. So then we'll have 23 is equal to 9 plus b. And then to get rid of the 9, subtract it. 23 minus 9. 14. So then our b would be 14. So now when we write this out as our equation, what's our equation going to look like? Too many numbers. There you go. Yeah, so you want to put the y and the x back in there. So you take that b, plug her back in, take that slope, plug her in, but you leave it as the x and the y. So it'd be like y equals 3x plus b, or plus our b is 14. Or with our actual letters in our problem, maybe we should switch this to w and l. So here our l would be like in the y position. So our length is equal to 3 times whatever the weight is, plus 14. Okay, so then doing this out here, we know our y-intercept's got to be 14. What do you want to count by here? And you go by well, so if we go by 2, 14 is going to end up way up here. Is our graph going to be going up or down? Up, right? Because this is a positive. So if we go 14 up here and then we try to go up, isn't it going to kind of go off our graph a little bit? You want to try 5s? Okay, so if we go 5, 10, 15, 20, and if you did it by 2s, that'd be fine. It's just going to go off the graph pretty quickly. We'll try 5, see what happens there. And then going across the other way, that's our weight in pounds. What do you think we would count by for pounds? 2 would be fine. You could also probably count by 1 there, and that'd be fine too. Okay, so if we start at 14 for our y-intercept, let's go up to 14 and put a point. And then for each weight increase we have of 1 pound, we go up 3, right? So if we went over 1 pound, what would our weight switch to? We're starting at 14 and we go up 3 for every pound, 3 inches for every pound. 17, right? Because it'd be like 3 times 1 plus 14 would be 17. So kind of between the 1 and the 2 would be 17. So then if we go up 2 pounds, 20, because that'd be an additional 3. And then up 3 from 20, 23. And then up 3 from 23, 26. And then you could just kind of keep going there. Would we want a line through this or not? Could we have partials of pounds? Yeah, we could weigh partials of pounds, right? So that would mean it's continuous. So you could have a line going through there, and it would just keep going up. Eventually, we know with the spring, if you put like 2,000 pounds on it, what's probably going to happen with the spring? It's going to break at some point, right? But for, you know, the distant future of what we know in this problem, we can put that arrow there that it's going to keep going up. Eventually, if we knew something about its breaking point, we could stop it somewhere, but we don't know that. Okay, so that's one with the graph. Next one here, find an equation of a line through the points 6, 4, and 15, negative 2. So here, it's up to you. It doesn't tell us if we need to have it in slope, intercept, and 4-point slope. Do you guys care which one we do? Maybe we try a point slope one here, okay? Because it doesn't tell us, and point slope's probably actually easier in this case. So here, we got our ordered pairs, x and y. When we do the point slope one, and again, you could use the other one as well. I don't care because it doesn't say. So that's our formula for point slope. So things we need here, we need the slope, and then we just need one of the points, okay, or one of the ordered pairs. Okay, so if we're calculating slope here, what do you think? So if we do the slope out, what is one of our y's? Negative 2. So if I go negative 2 minus 4 for our other y, what has to go under the negative 2? 15, because those are in an ordered pair together for the x, minus my other x, 6. So I just solve that out. So negative 2 minus 4, negative 6. And then 15 minus 6, 9. So we could have it as that, or what would that reduce to? Yep, 2/3. Yep, because we could take both of those and divide them by 3 to get that down to a 2 and a 3. One thing to talk about here, I've had a lot of questions on this recently. If this is negative, is the negative just with the 6? No. What that means is it is with the 6 up there, but it just means that whole fraction is negative. Okay, so like here, I just put it out front, just meaning the whole fraction is negative. So if you got a negative on the top, or if you had a negative on the bottom, that just means the whole fraction is negative, okay? Now if you had, say it was something like, don't write this, but say it was like a negative 6 over a negative 9, what is it in that case if it's a negative over a negative? That's a positive, okay? So just be careful with that. Like I said, you don't have to write that. But I've had a lot of questions about that lately. So if you have a negative there, it's just the whole fraction is negative. Okay, so that was our slope, right? So we can take that guy and put it in there, right? And then with this type of equation, the only other thing that we need is we just need one of those points. Do you care which one we use? No, it doesn't matter. So like say I put the 6 and the 4 in there, just be very careful here. Which of those is the y? The 4, so make sure you put that in the y position here. So it would be like y minus 4 is equal to, that slope is negative 2/3. And then parentheses x minus, and then our x coordinate that went with the 4 is the 6. So that goes there. So basically those guys, the y, or the x is going to that spot, and the y is going to that spot. Okay, and that would be fine because it just says find an equation. That is an equation. Now, if they specifically said one form or the other, then you'd have to switch it around. And sometimes the answer key will have one version versus another. I don't care. I'll work it out when you take the quiz. I just solve them out by hand and figure out if it's the same thing.
Does it matter what order of pair we choose?
So, okay, so good question here. Could I also have y minus, my other y coordinate is negative 2 is equal to negative 2/3, parentheses x minus 15? Would that work? It would work, yeah. So either of those would be fine answers, okay? And then it's kind of like, you remember the standard form thing, how like these equations look different, but they're actually the same exact thing when we graph them? It's the same concept. If you want something that's consistently the same every time, you turn it into slope-intercept like this one here, because slope-intercept is always going to be like, you know, y equals blah, 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 and it's going to be exactly those numbers. Here, the slopes are always the same, but the points there are different, because if you solve that out for y equals, they would end up being the same thing. Okay, but yes, that's a good question. Okay, cool on that? Okay, so we'll go to the next thing here. Okay, so this stuff is probably brand new to you guys, would be my guess. And I'm going to use 3 colors when I do the next example. If you've got 3 colors, that would be helpful. If you don't, over by Tinley there's like colored pencils and stuff. But I'm going to use 3 colors to kind of show the different parts of the graph. So if you want colors here, there's colored pencils there, there's markers. I can't guarantee the markers work, but we're going to do piecewise, which is like chunks of graphs. So get that jotted down, and then we'll talk through what that actually means. Lab rat advisory treats today if you want one before you leave.
Perfect. I'm also gonna come in after 6th period to finish my quiz.
We'll see, it's my second time making these. So.
What is it?
They're homemade payday bars. So it's like peanut butter, marshmallows, peanuts, like it's. I would sketch it. Yeah, we're gonna do it. It doesn't have to be exactly that. Like you could just have like something that's just like chunks of graph, something like that. But what we're going to start talking about here is piecewise stuff, which is just like graphs broken up into little parts, which you'll kind of see. But yeah, I do a little sketch of it just so you remember if they say the word piecewise what it is, but the next example deals with like how to actually figure it out. So we'll also do it on the next example.
You want that purple in a different color?
I just put it in a different color, but you don't have to. The next thing we do is where I'm going to use the colors. And you'll see why as we kind of go. Okay, so like I was kind of talking about there, so piecewise, has anyone heard of piecewise before? So you may have seen this like on map tests or something like that. So it's still the equation stuff, so it's still linear equations like we were doing before, but instead of it being the same style of line through the whole graph, there's little chunks of like lines that make up the graph. So like it's a union of several segments. So like see there how like that's a chunk of the graph, chunk of the graph, chunk of the graph. Each of those would have a different rate of change or slope for that. So that's why they call it piecewise, because we're going to figure out like all of those individual pieces, okay? And then it's each going to get its own equation with that, because like that, and that all have different slopes and y-intercepts, okay? So we'll look at this example here. What I'm going to do is I'm going to do each of these chunks of the graph in a different color. So let's just start by labeling our graph out here. I'm going to go out to 100 each way, counting by tens. And then I wish they wouldn't do this for our first time doing this, but they use P and Q instead of X and Y. But the P is kind of like our X position, and the Q is kind of like our Y position. So I'm just going to throw those labels on there as well. But that's just changing the letters. That doesn't really mean anything. And then what I'm going to do here, I'm going to graph each part of this graph in a different color. So like so basically it gives you 0 to 50, 40. I'm going to do that in a color. So I'm going to go from 0, 0, should be right there, to 50, 40, should be right there. And I'm going to connect that with a straight line in that color. And then I'm going to switch to my second color and do my next part of my graph there. So 50, 40 to 60, 60. So it's going to end at that point that we just left off there, 50, 40. And then we're jumping up to 60, 60. And then I'm going to do the same with my last one. I'm going to take my third color and do my last two. So the 60, 60 to the 100, 60. And that would just be like a horizontal line. And then what I'm going to do is each chunk of this graph, so basically we have to have an equation for this part, and this part. I'm going to do my solving of the equations in that same color. Or if you're doing it in highlighter, you can do it in pen and then just highlight over it in that same color, okay? So whatever your first color is, we're going to come up with an equation of line for just that first part, okay? So there are two ordered pairs. And again, I'm just using whatever my first color was. 0, 0, and 50, 40. Okay, so equation of a line here, first thing we need is slope. Okay, so if we're finding slope here, it would be, so we got x and y, what's going to go on the top? Yep, the 40 minus 0 for our y's, so 40 minus 0 over, and if we choose 40 first, what's the bottom half to be first? 50 for the x, minus our other x would be 0. So then when we solve that out, 40 minus 0, 40, 50 minus 0, 50, and what would that reduce to? 4/5, right? Because we could pull a 10 out of each of those. So our slope there would be 4/5. Now when we do this out, we're gonna put all of these in the y equals mx plus b form, because that's how the piecewise is always set up, so we're always gonna wanna get it to y equals. In this case, since it's touching our y, what's our y-intercept without even doing any solving? The 0, right? So we could do our plugging in, solving out, and find our b, but since that's already on our graph there at 0, wouldn't our y-intercept be 0? Yeah, so when we write our equation for this chunk of the line then, we're going to use the 4/5 as our slope, and again, instead of x and y, they want us to use the p and the q. So it would be q is equal to, slope is the 4/5, and then again, we don't have the x, we're going to put p in there instead. And then you could either put plus 0 at the back, or do we really need the plus 0? Not really, so you don't have to have that plus 0 at the back if you don't want to, but that would be our equation for that chunk of the line. Okay, so that's the first one. Now what I'm going to do, I'm going to switch colors, or if you don't have colors, you could just kind of draw a line there to show that you're on to your next one. So whatever your second color is, now we're going to do the same exact thing with our middle chunk of that line. So our points for this one, and again, I'm in my second color, are 50-40 and 60-60. Same thing there, we want to go through and find our slope. So to find our m, what's one of our x values? 60, or not x, I meant y. Either way, it's an x and a y in this case, but yeah, y's on top. So 60 minus, and what's our other y? 40. Over, if we chose 60 first for the y, we got to choose 60 first for the x, minus our other x, which is 50. Okay, so doing that out, if we go 60 minus 40, 20, 60 minus 50, 10. And what would that reduce to? 2 over 1, or isn't 2 over 1 just the same as 2?
Yes.
Yeah, so either of those would be fine for our slope. I don't care which one you use, okay? Okay, now here, is it going to be obvious what our y-intercept is in this case? No, it's not. So what we want to do in this case then is do our plugging in, just like we did from the previous page, to find that b value, okay? So we're going to start with one of our y-coordinates. Me personally, I would probably use the 60 and the 60, just so if I accidentally put the x and the y in the wrong place, does it matter if they're both 60? No. So if I ever see a situation like that, I usually use the one with the same numbers, because both my x and y are 60, so like in the y spot, I'll put a 60 is equal to, that slope we just found is 2, times my x coordinate that goes with the 60, which is also 60. And then that would be plus our b value that we're trying to find. So then we just start simplifying that out. So if I do 2 times 60, 120. So I'd have 60 is equal to 120 plus b. And then to get rid of the 120, subtract it. So that'd be negative 60 is equal to my b. So now I have my slope, or I have my slope is 2, and my y-intercept is negative 60. Is that enough to give me my equation then? Yep, so then I would go, again, we're using the q and the p, so q is equal to, what was my slope? 2. And then my x is p, and then my y-intercept was the negative 60, so minus 60. Okay. I'm running out of room going that way, so I'm going to do mine under my picture here for my third one. So I'm going to switch to my third color then. So third color, I got 60 as a point, and 160 as my other point. Okay, so with this one, same thing, want to start with our slope, x and y, x and y. Okay, what's one of our y values? 60. What's our other y value? 60, which means this is kind of a weird situation, right? Because since they're both 60, does it matter which one I put first on the bottom? It doesn't, because they're both 60. So like if I went like 100 minus 60 as my bottom, the reason that doesn't matter is because what is 60 minus 60? 0. And then the bottom in this case would be 40, or if you did it the other way, negative 40. But what's 0 divided by anything? You can't do it this one. What's the slope of our horizontals? 0. So the slope there is 0. And that happens, like I said, because that's a horizontal line. The straight up and down ones is where it's undefined. 0 can't be on the bottom of our fraction. Okay? So that's 0 there for the slope. And again, the y-intercept on this one's actually not too hard to calculate, because if this is a horizontal line, won't it just keep going across there? And if it was going across there, where would it stop at? It would hit at that 60, right? So wouldn't that make our b value a 60? So then what that does for our equation is basically it would make it like q is equal to 0 times p plus our b value 60. But really there, the 0p, do we need that? No. So isn't our q in that case always just going to be 60? Yeah. Okay, so that's our equation for that one. Okay, so now how this works to write this as like your actual answer. You do this in like the piecewise setup. So what it's going to look like, I'm just going to switch back to my regular pen here. You're going to have whatever your like y value is out front equals, and then you're going to have one of those big, I'm horrible at drawing those, but like those big curly brackets. And then we write this kind of like individual parts here. So like that first part was the q's equal to 4/5 p. So I'm just going to rewrite that in my color then. So whatever your first color was, I'm going to go 4/5 p, and I don't have to have the q equals because that's out front, because all of them are q equals. And then the additional thing that we add this to is we tell whoever's looking at this what part of the graph that equation works for. So it's kind of like the domain that would work for this. So what was the smallest value of the first part of our graph? 0. And what was the biggest value? 50. I'm just talking about that first chunk of the graph. So wouldn't that be going from 0 to 50 for like the domain? Yeah, so what we write here, so it's that equation. I'm going to go comma 4, and that's for when our values are from 0 is less than or equal to, p is our letter, usually it's x, but p is the letter we're plugging in for, and then less than or equal to 50. Okay, so what that's telling us is if you're from 0 to 50, you use that top equation. Okay, so done with first color. Second color then, I'm going to do the same thing. So this time my equation is the 2p minus 60. So again, the q equals is already out front, but I'm going to put that 2p minus 60 in there. That's my second equation. And then this is going to work for, and if we go back up to our graph here, what chunk of the graph, so like domain-wise again, from what to what is this going to work for? 50 to 60. Now here, since we've already had 50 up here and it was equal to, when we write our 50 here, we just do the less than sign. We don't do the equal to there because we already accounted for 50 there. No matter what, it'll put you in the same place. Then we put our p in the middle again. Then we go less than or equal to, and then the high end of that, like you guys just said, was the 60. So if your value falls between 50 and 60, like 55, you would use that equation to find your value. And then same thing for the last one. In this case, it's just q equals 60. So you would just have to put the 60 down there. You wouldn't have to put any letters or anything because it's just that horizontal line at 60. And then again, we'd go comma, and then this will work for. And then what was our x domain here for that section? To 100, right? So if I go from 60 to 100 on that x value, or the p in this case, that would be that last chunk of the graph. So this would be for 60 less than p less than or equal to 100. And our graph just stops at 100. We don't know what happens past that, so we just end it at 100. Okay, but again, we don't need the mark for the 60 there because 60 was included up top there. Okay, it's quite the process, but it's just solving equations like we've done lots and lots of times before, right? So it's just doing it, but doing it in little chunks of lines. Okay, and that's called piecewise. All right, so your book page there, 173, 1 to 16, but there's 3 of them you're going to skip. So skip number 5, skip number 10, and skip number 13.